Now that we have our database server installed and running on our system, we're going to discuss database design. And we're going to do this now before we talk any more about administration of the server, because we need to have a database that we can exercise on the server to test the performance. Recall that a database is a container. It's a container of data. It organizes the data in such a way so that we can get that data fast when we need it for our application. That's its primary function. Store the data, keep it safe, and when we ask with a SQL statement, give us that data as fast as possible so that we can feed the application and indirectly service our customers. One of the reasons we use a database system instead of, say, a flat file is because we're able to organize the data in the database system into tables, and those tables get related with one another, and the organization of the data within the tables and the tables within the database and the relations between those tables, all of that has a profound impact on the performance of the database system. So we need to learn how to build an efficient database. And like most design professions, a database architect has a set of tools and a language that is used in the design process. The standard for database design is an entity relation diagram. An ER diagram is simply a graphical representation of the tables, the data within the tables, and any relationship between the data in the tables. And because it's this visual representation, it's easy to discuss with other DBAs, with other architects, with the application developers, because a picture speaks 1,000 words. When we look at the ER diagram, we're going to see that there are entities, and these entities are represented by a rectangle, and the rectangle has a name, and within that rectangle are listed the attributes of that entity. The entity may represent something physical, like a person or a product, but it may also represent something conceptual. The important thing to remember about an entity is that every entity must be uniquely identifiable. That is, that it must have a unique attribute or set of attributes to be used as a key to identify that entity. A relation is basic to ER diagramming, entity relation diagramming. The relation defines the connection between any two data elements. When we build our ER diagram, we're going to have relations, we're going to have entities, the entities are going to have relations with one another, the entities will have attributes which translate to the columns in the table. Each column, each attribute, must be uniquely named within the table. They don't mix data types. So if we have a column defined as name, which is of type string, then all data within that column name will be of type string. Furthermore, every column has a domain, a range of possible values that can appear in that column. So as an introduction of what we're going to see in the ER diagram, an entity is represented by a rectangle. It's going to have a name. An attribute is going to be attached to an entity, and it will have a name, a unique name within that entity. For example, we could have two entities with the attribute name. That's okay because they're two separate entities. But we cannot have an entity with two attributes within that same entity called name. And then we have the relationship between two entities. This is the link between the data. The relationship defines the power of the database. Now again, keep in mind, we are focusing on relational databases. databases that support online transaction processing systems so that the relationship is the key that links the data across the tables in the database. There's a lot of theory behind database design, much of it amazingly useful for the database architect. For the beginning DBA, the subset of the world of database theory is much smaller. Cardinality refers to how entities relate to one another. Either there is a one-to-one relationship between an entity, a one-to-many relationship, or a many-to-many relationship. For example, a one-to-one relationship, we have a table named person, and we have another table that is related to that person table, say spouse. Then there is a one-to-one relationship between the person and the spouse table. On the other hand, if we have a person table and it has an attribute email address, a person can have multiple email addresses. Therefore, the table email address may contain more than one address for any one person. That would be a one-to-many relationship between the person and the email address table. Normally, on a day-to-day basis, the cardinality will either be 0 or 1. That is, that there will be 0 or 1 entities related to another entity one or more times. This will all make sense when we demonstrate the design principles with our ER tool. So, what are we going to use as an ER tool? As an architect, as a DBA that is responsible for designing databases to support applications, we need a tool. We need something that's going to allow us to draw pictures that we can take to the developers, that we can take to the application designers, and discuss the data layout within the database. There are many ER tools, and you're encouraged to search the internet and find an ER tool that you're comfortable with, that you find easy to use, because the ER diagram itself is the same no matter which tool generates it. In our demonstration, we're going to use the MySQL Workbench 6.0. It's both a design tool, a SQL development tool, and an administration tool, all rolled into one. It is absolutely free. It's visually driven and a wonderful tool. Now, for general administration, there are many, many, many other tools. One of the most popular for web-based administration is PHP MyAdmin. And you're welcome to load this on your system and use it to administer your MySQL instance. We will not be discussing PHP admin in this course. And again, you're encouraged to perform an internet search and find other administration tools, experiment with them, find one that you're comfortable with and that you find easy to use, that provides the functionality that you need, and use it. That's what's the most important thing, is a tool that you feel comfortable using. So let's go look at some code.